We have discussed what the longest common substring, or LCS problem is. It is finding a maximum length common subsequence between two sequences, such as words or bits, or even DNA sequences. Now let's try to explore how you might calculate the LCS. Let's use two words in this example. Here's a not so sophisticated way of trying to calculate the LCS. Let's line up the two words excellent and excitement, and wherever the two characters match, we can draw a line. But we're going to do this from left to right. So E matches with E, X with X, C with C, and then we have the second E in excellent. We can't draw a line back to the first E in excitement, but we can move forward. So we can draw a line forward with the second E in excitement. L, there is no match. The second L, again, there's no match. We can match ENT in the end of excellent to the last ENT in excitement. So we have 1, 2, 3, 4, 5, 6, 7. So the length of the LCS is 7, and the actual LCS is EXCEENT. Let's do this again with algorithm and alignment. A matches with A, L with L, G with G, nothing for O, nothing for R, and then we get to I. I could match with the third character in alignment, but that would be crossing a line. So the rule here is we're going to draw lines between similar characters, but we're not going to draw a line if the line crosses at a previous line. So we're going to not add I. T with T, there is no H, and then we get to M in algorithm. There is an M in alignment, but it would cross over the line for T and T, so we're going to ignore that. So the LCS for algorithm and alignment is ALGT with a length of 4. The simple technique we tried works, but probably isn't the best way to do this. It also wouldn't be very easy to automate. We could possibly automate a brute force approach that we see here. For every subsequence of X, check if it is a subsequence of Y. Well, let's analyze this for a second. There would be 2 to the m subsequences of X. If each check takes big O of n time, since we can scan Y for the first element and then scan for the second element and so on, the worst case running time is big O of n times 2 to the m, which is exponential. As you can imagine, this is terrible complexity, and as with most brute force solutions, isn't really the most appropriate way. Let's take the example of algorithm and alignment that we saw previously. That would mean that there's 4,608 comparisons, which is quite a bit for 2 short words. Next, we will introduce a much more efficient strategy to compute the LCS, this time using a table method. Please continue reading the course material to find out more.